Hey there, thanks for joining. Today we're going to be talking about closed loop systems. Most traditional systems don't really have loop systems in them. What basically a loop system is when the water is going through the pipe and it's going to all the sprinkler heads, eventually that pipe will make its way back around to an earlier part of the pipe to create a loop. They can be designed in many ways. You can put them on the main line, you can put them on the lateral lines, but before we talk about that, we need to know why loop systems are considered and kind of the reason people think of them. So basically, you got to remember in the irrigation systems, you're basically having water come from inside of your house, usually starting right at the water meter. Eventually, it has to make its way all the way outside through a bunch of variables, some elbows, some valves, this and that to make its way to the grass outside. So here, the two squares represent just a house, basic rectangular shaped house. So here I am drawing the main line all the way around the house. So what I'm doing is I'm creating a whole loop, and here I've drawn 4 valve boxes on the outside. The idea behind the main line loop is that at the valves, each valve is going to have the same amount of PSI. The water pressure coming out of the valves is all the same no matter where you are on that main line. On the right-hand side property, I'm drawing the main line out to some bigger valve boxes. So you need bigger ones because they're going to house a lot more valves. So then you're sort of, at this point, you're sort of counterproductive running pipe backwards. So in this demonstration here, it'd be obvious that you'd use the mainline loop instead of using the one on the right because you're just using a lot more material. So here on the bottom right, I have 2 little examples of zones. One on the top is not a closed system, and the one on the bottom is a closed system. Here I am just drawing in a couple sprinkler heads. Once the lines are filled with water, eventually the pressure works its way backwards. So here, for example, has a lot of weight to it. The water is just sort of sitting there, has a bit of weight to it, and a portion of the line closer to the source is somewhat heavy. So basically what's going on is the water is going to take the path of least resistance, and these sprinkler heads closer to the source are going to have more pressure, and then the ones further down the line are going to consistently lose more and more pressure the further it goes. And possibly the sprinkler head at the very end might not have any pressure at all, it might not even pop up. Example on the bottom with the loop system, with the 4 sprinkler heads in the same spot, when the lines get plenished up with water, eventually all the forces balance out, and then each sprinkler head has the same amount of pressure no matter where you are on that loop. So I actually have a real example. So this picture here, I drew back in 2016 in the wintertime. I was already out there in the late fall, already kind of got an idea of the guy's house. So I drew this up over the winter. I knew I had to use a loop system on this one. So on the side view, we can see that it's roughly about 125 feet from the back to the front. Let's call it 120 feet because we're kind of give or take. And then on the image on the left, we see it's about 70 feet wide. Also, you see where the water comes out on, near beside the garage, near the front. So this customer's house was right on the property line, and we had to run the water all the way around the back of the house. There's no option to go underneath the driveway. The driveway was much too wide. So the main line, even before we hit the valve box, is running about 140 feet. And then it has to go about 120 feet, but 12 feet up into the air. Knew I had to use a loop system on this one. Quickly, I'll just show you what an incline will do to your water pressure. 1 foot of head will give you 0.433 psi. And what a head is basically 1 inch by 1 inch by 12 inches. You can just imagine a vertical column, 1 inch by 1 inch, 12 inches high. That amount of water will give you 0.433 psi at the bottom. So back at this customer's house, I have to go about 12 foot high from the valve box to the first zone out in the front. Then what you want to do is you want to basically multiply the height you're going at the 1 foot of head psi, and that'll give you the answer that you need of how much psi loss you're going to have just from the height alone. So at this customer's house, he was losing about 5.2 psi. So that's just considering the height and the weight of the water having to push it uphill. There's a lot of other variables that can be talked about, but basically the backflow device has some check valves in it, which will reduce it about 4 psi. Irrigation valves, you lose roughly about 2 psi, but the good news is they're usually only running one at a time. Sprinkler heads lose about 1 psi when they pop up. Rotors are anywhere, depending what kind of rotor you have, but let's just go with about 4 psi because they have a lot stronger spring inside of them. And multiply that by how many sprinkler heads you have on your line, and then you have your equation of how much psi you're going to lose from your water meter to the last sprinkler head on the line. Just for the purpose of the example here, we're losing about 7 psi on all the other variables, the backflow device, the irrigation valves, and the heads. Also adding the psi loss of the height alone. So already looking at about 12.2 psi loss. I do want to point out here that you see on zone number 2, I did not create a loop there. The water basically goes uphill, turns around and comes back downhill and kind of null and voids the pressure loss there because it goes up but then it comes back down equally. And here's a picture of that zone 2 working here just fine.